Good morning, students. Today we taught about the properties of waves. This is the summary that we will discuss in this topic. The first properties of waves is the amplitude. The amplitude is the maximum displacement of particle from its mean position. As see in the figure, this peak shows that the crust. So see, we say that the highest, yeah, or the height of the crust from its mean position, this is the mean position of particles, or the depth of the trough from its mean position of particle, it's called the amplitude, and it is denoted by A. Next is the wavelength. The wavelength is the distance between two nearest crust or trough of waves. So we see that in this figure, this peak points shows the crust. So we say that the distance between two nearest crust or the distance between the two nearest trough, it's called the wavelength, and it's measured in meter and it is denoted by the lambda. Next is the period. The period of wave is the time for a particle on a medium to make one complete vibrational cycle. So we say that when the particle it's complete our one vibrational cycles, we see that in this figure, this portion, the particles or the wave is the time for a particles make one complete vibrational cycle. So its portion or it is called the time period. As the period in is in time, so we say that the unit of period is second or minute. Next is the frequency. The frequency of waves is the number of waves passing a point in certain time. When a wave passing a passing a point in certain time, as we see in this figure, this axis shows the time. So we say that this is the frequency. In this figure we see that there is the two frequency, one is the more frequency and another is the lesser frequency, because the formula of frequency is equal to 1 wave per second. So the formula is met is frequency is equal to 1 upon time period. So on this basis we say that when the time period is minimum, when the time period is minimum, so frequency is more than. So that's why this figure shows the more frequency, and the other figure, this figure is lesser frequency because of the time period of one complete vibrational cycle is very high or its maximum, so the frequency is minimum. So we say that when the time period is minimum, so frequency is very high, and the time period is maximum, the frequency is very low. So its work, it's a as a reciprocal between frequency or the time period. Next is the wave velocity. The wave velocity of waves refers to the distance traveled by the waves in 1 second, and it is denoted by V. Here is the formula of the wave velocity. V is equal to n lambda, where n is the frequency and lambda is the wavelength. Next one is the phase. The phase describe the state of motion. It is describe the wave of motion when point on a wave point on a wave which travel in same direction. This graph we see that the points of waves travel in same direction. The rising and falling direction is same in this graph, so we say that the waves in phase with each other. Or in other another graph we see that the rising and falling point of waves, the travel direction is not same. It is very opposite to each other. So we say that this waves is perfectly out of phase. Next is the angular wave number. The angular wave number is the spatial frequency of our waves in terms of cycle per unit distance. Here in this graph we see that this portion shows that the wavelength, or it is also shown that the one complete cycle. So the wave numbers, we see that the frequency of a waves in terms of cycle per unit distance. Next is the angular frequency. The angular frequency is defined as the angular displacement per unit time of the rate of change of phase of waveform. Okay, when we our phase is change of a waveform, so the angular displacement, this one frequency, yeah, angular displacement per unit time, it also change. So we say that the angular frequency is the angular displacement per unit time of rate of change the phase of a waveform, and this formula is mathematical. It is can be represented by the omega is equal to 2 pi upon t, where t is the time period. And when we this angular frequency, when we describe in a frequency term, so we represent as a v is equal to 2 pi f. Thank you.